So, I might put my last year's videos, or maybe 2 or 3 years old, let's be honest, full lesson on our calendar, and then this one last, and I'll denote that. So, um, probably too late if you open up the other ones. Those will be the full lessons for anyone that was absent, which was nobody, or anyone that wants to see all these worked out again. But starting with 5, and of course the second one from 3 years ago ends with this. I think both classes we were very similar in where we ended up here. Just read your directions. So this is trying to say rewrite this as a single radical. Well, I did get through with this with second hour. I think this was the last one. We broke this down. The fifth root of n is n to the 1/5. That's that rule that we talked about. What's the fourth root of something? Well, that's raised to the 1/4 power. So this is how we analyze, how do I get a single radical out of this? Well, what you can do is use an exponent rule that says multiply these exponents. And that becomes 1 to the 1 times 1 over 5 times 4. And then to rewrite this as a single radical, I turn this back around and rewrite it as the 20th root of n. So what we did is made up an identity, I guess. If you have a root of a number, that's equal to the indexes multiplied together root of that number. I know I didn't say that very well mathematically, but trying to expedite this process so you don't have to listen to a very long video. So now this is where this is one of those questions, why are we doing this? And I don't have a great answer for you, but what it does make you do is use a lot of rules that you should know. Like rule number 1, don't do nothing, do something. So change this to y to the 1/3. I know how to do that. I know how to change this to y to the 1/4. No, the y's don't cancel. You can't cancel the y's when the indexes are different. This is not a reduce it situation. You can only reduce it if the indexes were equal. But now that I write this, maybe your Algebra 2 skills, I'm saying it. There's a great class that doesn't exist in this school anymore. Your Algebra 2 skills kick in. What do I do with these exponents when I have y over y? And the answer is subtract. So I know this is kind of ridiculous little question. It's making you use these rules that you kind of should know, but whatever. So what do I multiply this by and this by so that I can subtract, which is what my 4th grader's doing right now. And the answer is you multiply by 4. And you multiply by 3. And then this becomes y to the 4 minus 3, which is 1/12. And then what this becomes then is the 12th root of y. Now be careful on trying to make up a rule on this. It does end up being that 3 times 4 is 12, but I don't know. That one's a little bit tougher to come up with an extrapolation when you're dividing. Does that always occur? I know this always occurs. Oh, brother. Okay, sorry, that was a little interruption there. All right, then this next one. Rewrite as a single radical. So again, n to the 1/3. Again, n to the 4/5. But now we have a different rule in action. And that is, what do you do when you have n times n? When you have n times n, you add the fractions. So that's just this rule without fractions. What's n squared times n to the 3rd? It's n to the 5th, because this is nn, this is nnn. That's 5 n's multiplied together. So basically the quick way to do this is just add the 2 and the 3. So the rule is you add the exponents when you have n times n. You add the exponents when you have n times n. But in order to add these, you have to get a common denominator. And then that's the grade school part of it, inserted in a calc or pre-calc question. So this is n to the 5 plus 12, which is 17, over 15. Now what's interesting about this is the directions are rewrite this as a single radical. So I have an opportunity to mark you wrong, but I guess that would be kind of a jerky thing to do. Because where I can mark you wrong is something can come out of this. And a 15th root requires something multiplied by itself 15 times. There is n to the 15th in there. And there is n squared left over in jail. So this is n to the 15th times n squared. The 15th root of n to the 15th is n. So really we should think about if we had to rewrite this as a single radical, we should also write it as a simplified radical. Pretty tough. Now, this is where I hope the dog, you were listening and you listened to this video and actually watch it. I'm checking the views, seeing how many people actually do this. If they start with fractional exponents and it says simplify, your answer could be in fractional exponents when you're done. If the question starts as a radical and it says simplify, end it in radical form. I know that can be confusing. There's a lot of each of those types of questions in this section. So start as a radical question, end in radical form. Don't change it to exponent form, fractional exponents. If it starts as a fractional exponent question, end as a fractional exponent question. That can be confusing if you don't listen to that. All right, so what do we do in this question to simplify? You take the ends and group them because multiplication is commutative. If it's multiplication all the way across, I can rearrange this. Right, all right. And then what we have to do is, what's n times n? What do you do with these exponents? You add them. So this is just like the last question. What's the rule when you take y times y? You add the exponents. All right. The only thing I have to do is change this to over 3. This is multiplied by 3, both top and bottom. This is what I mean about this. This is 18 over 3. 18 plus 2 is 20 over 3 times y to the 4 over 3. Now, if you turn this into a radical, then you'd have to simplify. There'd be some n's that could be coming out, just like this last question. But that's my point. This gets real crazy. If it starts as a fractional exponent, the answer should end as a fractional exponent. You're done. Don't worry about changing that to a radical and then doing more things. And then this question starts as a radical simplified question. End with a radical, not fractional exponent. Remember, root it, reduce it, rationalize it. Remember, I said these two are do either or both at the same time. This is always last. So do not try to rationalize 16n with a fourth root before you check these two things. For instance, fourth root of 16, is that something or nothing? And hopefully you're answering, Internet, Mr. Samuelus, that the fourth root of 16 is 2 freedom. But this is interesting. Okay, so, all right, let's put a fourth root down here and see what's left over, and a fourth root up here. I've done nothing so far. Everything is here up there. But then another thing, fourth root of a fraction, can I reduce the n to the fifth and the n? And the answer to that is yes. So I fourth rooted 16, that freed out a 2. I canceled this n with this n to the fifth to make this n to the fourth. And then the glory and power of rooting and reducing before rationalizing. What's the fourth root of 1? Yes, student at home listening to the Internet, Mr. Samuelus. 1. 1 times 2 is 2. All right, then you're going to make a mistake, though. This is simplifiable. So through rooting and reducing, we got rid of the radical in the denominator. And then we also have something nice left over that we can pull out of that numerator radical. And then remember, we don't care that there's a radical in the numerator. All right, let me zoom back and see if there was anything else that I wanted to do. And then don't worry, that's not the assignment. I'm making it 1 through 81 or 83, every other odd. I'm going to see what happens. So check the calendar. Okay.